came across a new word the other day, and it's always nice to come across a new word. I haven't found a way to put it into a sentence yet, but I will, I'm sure. But the word was chreode, C-H-R-O-E-D-E, and I think it was initially coined by somebody called Waddington, but it may not have been. It may predate that. What it means is it's a word which describes a particular kind of landscape. Not necessarily a geographical landscape, in fact I haven't yet seen it applying to a geographical landscape, although I guess it could, but to a kind of probability landscape, or a developmental landscape, a kind of three-dimensional map, I feel like, that would be produced, three-dimensional graph, I feel like, would be produced if certain kinds of development were followed, certain kinds of probability were followed. And the usual example of how that's... sit on, pups, go on, sit up. The usual example of how that's described is it was actually an experiment that I did when I was at school years ago, actually. We did it in geography. And what we did in this particular experiment, or demonstration I suppose, is our geography teacher got this large tray, like a cat litter tray, a bit bigger, and it had a layer of sand about an inch thick in the bottom of it, perfectly smooth, very flat. And what he did was he propped one end of the cat litter tray up so it was at an incline, and then started to trickle water into the top. And I guess what you might imagine happens is that the water just runs in a straight line down through the sand to the bottom. But that's not what happens actually. What happens is as it works its way down the sand, it starts to meander a bit, and the meander gets larger and larger actually, and sometimes it actually breaks off and forms little tributaries. And then once it is formed, once that sort of stream structure has been formed, then you just, all the water you pour in beyond that point just stays within that within the boundaries of that path that it's carved. There's something chaotic about it. We do it twice, even though everything seems to be the same. We get different patterns forming, so it's very sensitive to initial conditions and the way that chaotic systems are. But also this feature I've mentioned, whereby once the path is established, then it continues to be followed, is very typical of chreodic structures, I guess. Which is that, one or two other examples actually made it really clear for me. Because apparently a lot of chreodes are found in biology, and the three that I've come across recently in reading about this are to do with evolutionary development, embryonic development, and the development of from stem cells to specific cells that make up the embryo, and neuronal development, I suppose, the formation of neuronal pathways. And what happens in each of those cases is that some kind of initial state is created. So at the beginning of the evolutionary tree, there's, I don't know, some kind of prokaryotic cell, or maybe a eukaryotic cell is needed for it, and that's a single-celled organism. And then various adaptation processes happen using the kinds of Darwinian and post-Darwinian processes that we know about. Those processes take place which allow development to take place. But these developments, once they're kind of made, once that path of development is made, it becomes increasingly difficult for that particular path to be reversed or to be stepped outside of and into a different path. So once an animal has started to develop a certain way, it's quite hard to develop a completely different way. Like we, for example, have developed in this 2 arms, 2 legs kind of configuration. It would be very difficult, it would just be impossible for us now to suddenly sprout wings. We've followed a different chreodic pathway somewhere in our past. at the point where we branched, I guess, from those certain dinosaurs that eventually became birds, we took a different chreodic pathway. Our droplets of water trickled in a slightly different direction than the lithotree at that point. So that's one example of chreodes. The second example was to do with stem cells, which that process seems to be again present in embryonic development, which is that at the outset of the development of the embryo, when there is just stem cells, the basic cells, they're very, very multivalent. In a sense, they could develop into lots of different things. A stem cell can develop into a kidney cell, or a brain cell, or a skin cell, or whatever else, which I guess is why they're so valuable in therapeutic context. But let's go back this way, folks. But once they do start developing, days or weeks or months into the process, they kind of commit themselves to being certain kinds of cells. They kind of commit to being a liver cell or a brain cell or a skin cell or whatever, and they take that particular tributary of or they allow that tributary to follow that down that valley in this kind of chreodic landscape that's being created. The third example from biology was to do with what I mentioned before, I think, although I haven't used the term chreodes before, which is to do with how ideas propagate, or concepts propagate, how ideas flow to the brain, thoughts flow to the brain. It seems to be that there are pathways which are chains of association between different neurons across these synapses, and there's thousands and thousands of them all connecting up, and most of them looping back on themselves and doing all this very complicated networking process. But not all those connections. Well, I guess at some point maybe some of those connections are equally weighted, or kind of flat in the great lithotree of our brain. But once ideas start flowing across them, they strengthen the connections. They strengthen the weighting of those connections, make it more likely that those connections will be followed next time around. Next time a thought passes that way, it's increasingly likely that a thought will go down that particular groove, and the tributaries start to form. And it becomes increasingly difficult to back out of that, because the path becomes very well established. So those are chreodes, as I understand it. I think it has application outside of biology. I've certainly seen at least one kind of economic application of it, and I've read somewhere about, I guess also kind of economic, about the way that markets work. So when the playing field on which microcomputers and desktops were being developed was flat, it could have gone any way in terms of which particular products hit the market and developed and became the industry standard or whatever. But Microsoft, through whatever processes they use, managed to create a very deep fold in the probability landscape, a kind of chreode. And once that developmental process is initiated, it's very difficult to back out of it, because lots of industries and corporations and governments and individuals have already committed themselves to a certain operating system, for example, in that case, and the chreodic landscape gets more and more valleyed into that point.